Good day, class. Today we're going to discuss the last mathematical tool needed in the study of physics. In physics, problems require us to use formula or equations. But sometimes, some physics problems ask us to compute for the unknown value or for the unknown variable without a direct formula to be used. Rearranging formulas or rewriting them in different ways is an important tool in the study of physics. That's the reason why our focus has something to do with the topic manipulating equations. What does manipulating equations mean? It means that you rearrange the equation so that the unknown variable you are trying to calculate is on its own on one side of the equation. To put this into simpler concept, manipulating equations, the rules that I'm going to explain later will help us to work with the general equations for us to have a derived equations that can be used in order for us to solve for unknown quantity or unknown values. But before we go through to the different rules concerning the manipulating equations topic, let's try to focus first with this common equation used in the study of physics. This is the equation for speed. And in order for us to calculate the speed of an object, we have to be familiar with the symbols. As pointed by the cursor, the small letter V here means speed. The small letter D here means the distance. And the T here means the time. So in order for us to get or to have an idea about how fast an object moves, we have to be mindful about the values for the distance and the values for the time, because speed is the ratio of distance per time. Okay, so remember that on the right, on the left hand side of the equation, this variable or the letter that you will see here is the subject of the formula, known to be the subject of the formula. So in this case, as we go along with the different rules about manipulating equations, we have to make other variables, okay, be the subject of the formula. And that will help us to get an idea how come that we have this formula for finding the value of the distance as long as we have values for the speed and the time. And also, this concept will help us to answer this question that what is the right equation to be used if we're looking for the value of time. As long as we have values for distance and speed, we can go ahead and proceed computing for the value of time. So again, you might wonder how possible that we have this kind of equations as pointed by the cursor from this general equation. Okay, so as mentioned earlier, what we're going to study here in manipulating equations is for us to rearrange the general equation into derived equations that can be used in order for us to solve values for other variables found on the equation. Because remember, there are chances that we are not just solving for the subject of the formula from your general equation, we are solving also values of the other variables as part of the general equation. And for us to have an equation for that, we have to rearrange them in order for us to make the unknown variable be the subject of the equation. Now, let's familiarize ourselves with the different rules governing the topic manipulating equations. Now, in this first rule, we can do any of the two in changing the subject of a formula, add or subtract the same quantity to or from both sides of the equation, multiply or divide both sides of the equation by the same quantity. Now, the quantity that we're referring to in this rule are or is the quantity that we have to exclude from the side of the equation, which we can see the variable that we have to make as the subject of the formula. Now, to apply these rules, let's have an examples. In this case, we have to make x the subject of the formula. For number 1, we have a plus x equal to y plus z. For number 2, we have ax equal to y plus z. Now again, we have to make x be the subject of the formula. So before we go ahead and decide which rules are we going to apply in order to make x be the subject of the formula in these cases, we have to properly analyze it first. So are we gonna add or subtract same quantity on both sides of the equation, or are we gonna multiply or divide both same quantity on both sides of the equation? Now, to further intensify that part, let's move to number 1. We know what to do. We have to make x the subject of the formula. So we have this a plus x equal to y plus z. So upon analyzing, we know for a fact that x as part of the variables found on the left hand side of the equation, we see a and x. And again, x is the subject of the formula. We have to make x be the subject of the formula. Now, in this case, we have to exclude this quantity. How can we exclude it? How can we remove it from this side of the equation in order for us to maintain only x in this side of the equation? Good. We have to subtract quantity a, this variable, on both sides of the equation. Good. Now, by doing that, we have this a minus a, and we have y plus z minus a on this side of the equation. Now, that's the time that we can go ahead and exclude or cancel a minus a on this side of the equation, leaving only x. Why? Because a minus a is just 0. Now, in your mathematics subjects, from what you've learned, you can transpose this variable to the other side of the equation. So this is positive. When you transpose it on the other side, this becomes negative. Now, vice versa, if you have negative variable here, once you transpose that on the other side, that becomes positive. So therefore, our answer in this case is x equal to y plus z minus a. So this is now a derived equation in order for us to solve for the variable x, and that came from this general equation. And the rule that we apply here is the rule which says that we can add or subtract same quantity on both sides of the equation, but the operation that we did in this case is subtraction. Now, let's go ahead and proceed to example number 2, and let's try to apply the rule that I mentioned earlier. Now, same procedure, we have to make x the subject of the formula. We have here ax equal to y plus z. So, as we analyze it, we know for a fact that in this side of the equation, left-hand side of the equation, this is multiplication. The operation between a and x is multiplication. Okay. Now, inverse operation for multiplication is division, right? And in order for us to remove a in this side of the equation as part of your x, we have to divide both sides by the quantity a. Okay. Still, we apply the rule mentioned earlier. So, through that, we have ax over a equal to y plus z over a. The letter a here, or the variable a, here on this equation, as pointed by the cursor, came from the idea that we have to divide both sides by the quantity a in order for us to remove a on this side of the x variable. So through that, we can now cancel a here. So cancel a, remaining only the x variable. Therefore, our answer in this case is x equal to y plus z over a. So again, this is now the derived equation, and this came from this general equation. And what we did here is that we cancel a by dividing both sides by the quantity a. Now, let's proceed to another rule. Now, in this rule, for formula with brackets, we know for a fact that there are equations with brackets involved on it. So in order for us to manipulate it, we have to expand the equation. In order for us to remove the bracket on the general equation. And again, just to give everyone a heads up, we can still use the first rule that I mentioned earlier, that I discussed earlier in this case, in order for us to have a simplified equation or the simplified derived equation from the general equation. So again, we have to expand the equation. And in order for us to do this rule, we use the concept you've learned in math, which is the distributive property. Now, let's go ahead and apply this second rule in these examples. Still, same procedure. We have to make x the subject of the formula. For number one, we have a, open close parenthesis, x plus b equals to c. For number two, we have x over a equals to y plus z over b. So let's focus first on number one. Now we have this equation. Still, we have to make x the subject of the formula. And you've noticed that there are brackets found on the left-hand side of the equation. Now, as per the rule, we have to remove these brackets by expanding the equation through distributive property. So, what we're going to distribute inside this parenthesis sign, the variables inside the parenthesis sign, is your variable a. Now, a multiplied to x, because the bracket means multiplication, so we have to multiply a to x, likewise a to b. Now, doing that, we have this solution. As part of the solution, ax plus ab equals to c. Again, the reason why we have this ax plus ab equal to c, that's simply because we multiply a in each variable found inside the parenthesis. Now, we're not yet done here, because what we're after is to maintain x, and that is the subject of the formula that we are working on. So upon checking, upon analyzing, we cannot go ahead and remove a from x here, because we have to work first removing ab as part of the variables in the left-hand side of the equation. And through that, we can use the first rule that I discussed earlier. And upon checking, we have to subtract both sides by the quantity AB, both sides of the equation AB, in order for us to remove AB on this side of the equation, leaving only your AX. So through that, we have this one, AX plus AB minus AB. So the minus AB came from the idea that we have to remove AB from this side of the equation, and that can be done by subtracting both sides by the quantity AB. So that's the reason why also we have C minus AB in this right hand side of the equation. So we know for a fact that AB minus AB is 0, so we can go ahead and cancel that. So leaving only A x equal to C minus AB. Now, you might wonder why is it that there are variables A in this part of the solution. Now, the next step that we have to do is to remove A in this side of X. Okay, and by doing that, we do the inverse operation because between a and x, the operation here is multiplication. So we can cancel a in this part of the equation by dividing both sides by the quantity a. So that is the rule you've learned earlier, the first rule that you've learned earlier. Now we can go ahead and cancel that, leaving only x in this left hand side of the equation. Now that is the subject of the formula. Now your x equal to c minus ab over a. So again, from this solution and from this general equation, we can now go ahead and solve for x because we apply the second rule you've learned and the first rule you've learned earlier. So again, just to give everyone a heads up, we're going to use, as we move forward, the different rules you've learned earlier. So this is not just the rules that I'm explaining is not just for a particular equation. That can be applied also in different equations depending on the situation. Now, let's proceed to example number 2. In this case, we have x over a equals to y plus z over b, and upon analyzing it, this is a fractional equation. There are no brackets found on this equation. Now, in this case, we can still apply the rules you've learned earlier, but for the meantime, we have to remove the fractional form of this equation, and we can do that by identifying the common denominator. Okay, the common denominator from this equation. Now, this equation, the equation comprises of variables, letters, and we can't identify the common denominator. The same procedure you've done before when you're dealing with fractions. In numerical form. Remember, what you did there is doing the inverse division. Okay, so in this case, we can go ahead and exclude the fractional form in this equation by multiplying both sides by AB, because this is division. Inverse operation is multiplication. YAB, A and B are the denominator here, so therefore those variables are now the common denominator. So multiply both sides by AB. Now, you can go ahead and proceed to the next step. We multiply AB to x and divide it to A. Now, to make life easier, we can go ahead and cancel A. The only thing that you have to multiply to your x is the B. And same thing in this side of the equation. No need for you to multiply AB to y and AB to x and dividing it to b, because you can definitely go ahead and exclude b on this side of the equation. So leaving only a. Now, next step from what you've learned earlier, you can now multiply. We have this bracket, so we have to expand the equation by multiplying b to x, likewise a to y and z. So therefore, we have this one as part of the solution. Bx equal to ay plus ax. Now, the b here, the reason why we have b here, because upon checking this one, in order for us to remove b on this side of the equation, we have to do the inverse operation of multiplication, that is division. So we have to divide same quantity, both sides of the equation, which is your b, in order for us to remove b on this side of the equation. That's the reason why we have b in this case. Okay, so cancel b, leaving only your x. And the answer now is x equal to ay plus az over b. Again, I want to reiterate it to everybody that the first step that we did is that we have to identify the common denominator from this equation in order for us to remove the fractional form of it. And this is division, this is fraction eh. So we have to multiply the common denominator on both sides of the equation. So the common denominator here is AB, so we multiply that on both sides of the equation. Now we cancel common terms here on both sides of the equation to make the equation as easy as possible in terms of simplifying it. So we multiply B now to your x, likewise A to your y and z. So having bx equal to ay plus az. Now in this case, what we're after here is just x, so that's the reason why we divide both sides by b. Okay? Hopefully you understand the whole procedure in this example, and having this kind of answer, which is x equal to ay plus az over b. Now let's have the rule number 3. For formula which require factorizing first, here's the thing that we have to apply. When changing the subject, start by collecting the term that you want on one side of the equation. So this is more about the subject of the formula. So we have to collect them because there are chances that the variable that we have to make as the subject of the formula, minsan di lang sila isa. There are chances that is more than one. Okay, we have to collect them on the side which is on the left-hand side of the equation to easily work with them. If this term appears more than once, then factorize before proceeding further. So we have to collect the variable on the correct side of the equation. Then we have to factorize it in order to have one variable only. The reason why we have to factorize it simply because of a chance that we have more than one variable referring to the subject of the formula. So to further intensify this concept, this rule, let's have an examples. Same procedure, we have to make x the subject of the formula. So for number 1, we have a open close parenthesis x plus y equals to b open close parenthesis x plus y. For number 2, we have y is equal to x plus a over x minus a. So again, I wanna emphasize this as part of the rule. We have to collect the term on the correct side of the equation. This is more about the term that we have to make as the subject of the formula. Now, there are chances that the variable intended for the subject of the formula appears more than once. So we have to factor or factorize it, okay, to have only one variable for the subject of the formula. Now, let's have example number 1. So here we have a open close parenthesis x plus y is equal to b open close parenthesis x plus y. Now, same procedure, same rules na natutunan earlier. We have brackets here found in the equation. So first we have to expand it through distributive property. So we have to distribute a inside the parenthesis in this one as pointed by the cursor. Also a to your y. So a to x, a to y. You have to do the same procedure. For your b, you have to distribute that to x and to y. So through that, we have ax plus ay equals to bx plus by. So we're not yet done. We have to properly analyze it. What rule are we going to apply in this part of the solution? So you've noticed that there are two variables for x, and from what you've learned earlier, for this particular rule, we have to collect them on the correct side. So we have to transpose bx in this side of the equation as pointed by the cursor. Likewise, ay to this side of the equation as pointed by the cursor. So that's the reason why we have ax minus bx equals to by minus ay. Again, you might wondering why is it that this is now minus or minus as the operation, simply because this is positive. When you transpose it to the other side, this becomes negative. So also your positive ay becomes negative on this side because we transpose it. Okay, so we collect them on the right side of the equation. So the next step that we have to do is to factor this particular side of the equation, because we're only after having one variable for this object. So that's the reason why we have to factor this one, not this one, because not because y is not the variable for the subject of the formula in this case. So that's the reason why we're only working for factorizing this part of the equation. So when we factor this one, from what you've learned in math, we have to think of a way wherein we have only one x as part of the equation. So we can have this answer, x, open close parenthesis, a minus b, because when you expand this equation, okay, when you multiply x to a, x to negative b, this is the answer, right? So don't you worry, we can go ahead and proceed in removing the bracket in this side of the equation, the brackets inside the equation. Okay, but again, the thing that we're going to apply here is not distributive property, because we have to properly analyze the solution. So upon analyzing it, you've noticed that x and the variables inside the parenthesis indicates multiplication operation. So inverse property of that, in order for us to remove this parenthesis sign, a minus b, is through dividing both sides by this quantity a minus b. So through that, we have this x, open close parenthesis, a minus b over a minus b is equal to by minus ay over a minus b. Again, the reason why we have this denominator a minus b in this solution, that came from the idea that we have to remove a minus b in this side of the equation, and that happens through dividing both sides of the equation by this quantity a minus b. So we can go ahead and cancel a minus b, leaving only x. So the answer here is x is equal to by minus ay over a minus b. Hopefully, you understand the whole procedure. In this case, we started from distributing, from expanding the equation by multiplying a to x plus y, b to x plus y. We collect them. We collect the common terms on the right side of the equation, on the correct side of the equation. So we just interchange them. We just transpose the variables on the right side of the equation. So we factor this part of the solution because we're only after with having one x variable for this equation, because x is the subject of the formula that we're working on in this case. So this is the factor for this ax minus bx. So cancel this a minus b, we divide both sides by a minus b, leaving only your x. So that's the reason why we have x is equal to by minus ay over a minus b. Now let's proceed to example number 2. So a bit challenging, right? So again, as mentioned earlier, we're incorporating other rules you've learned from number 1, from number 2, and moving on. Okay. Now this is also a fractional equation. So you have already an idea that we have to make this equation not in a fractional form. Okay. So in this case, we have to remove the fractions by multiplying, good, multiplying both sides of the equation with x minus a. So through that, we have this one as part of the solution, both sides, x minus a. Again, we are making this equation not in a fractional form. We multiply both sides by this denominator, x minus a. So x minus a multiplied to y is, before we work with that case, we can go ahead and cancel common terms here now. So as pointed by the cursor, we cancel x minus a and x minus a here. Now you can go ahead and multiply x minus a to y. So having this y, open close parenthesis, x minus a equal to x plus a. So we cancel it already, so no need for you to multiply x minus a in this case. So we have still a bracket here. We can expand it further. So y multiplied to x and also y multiplied to a. So what we have here is x minus y, xy rather, minus ay. That came from this part of the solution, equals to x plus a. So we have to combine or collect terms on the right side of the equation. So we have to move rather x to this side of the equation by transposing it here. Likewise, ay moving this to this side of the equation. So you know the drill. So xy minus x, positive, transposing it to the other side becomes negative. Negative transposing to the other side becomes positive. So the reason why we have a plus ay in this side of the equation. Now we have to factor this one. Okay, because we have two variables for x, we should only have one. So in order to do that, we have to factorize this one. So the factor of this one is x, open close parenthesis, y minus 1. So when you distribute it, this is the answer, right? Okay, good. Now we have to remove y minus a in this side of the equation to have x only on this left hand side of the equation, because this is the subject of the formula, and we can only do that by dividing both sides by this quantity, because the operation between x and the variables inside the parenthesis is multiplication. Inverse operation is division. So putting that concept into this solution, x open close parenthesis y minus 1 over y minus 1 is equal to a plus ay over y minus 1. This denominators came from the idea that we have to eliminate y minus 1 in this part of your x, and we do that by dividing both sides by this quantity. Okay, so we can go ahead and divide that, cancel that. So cancel y minus 1 and y minus 1, leaving only your x, and therefore our answer for this case, okay, is x is equal to a plus ay over y minus 1. Okay, so hopefully you mastered the rules. So again, we're using rules from the first to second up to this rule. Now let's have the last rule for manipulating equations. Now there are chances that we have equations with roots and powers. So in order to properly manipulate it, we have to square or cube both sides of the equation. So remember, square and square root are inverse functions. That's the reason why we have to square both sides of the equation. Likewise, cube and cube root, both of them are inverse functions. So there are chances that we have to cube both sides of the equation. So to further understand this rule, let's have examples. Same procedure, we have to make x the subject of the formula. For number 1, we have square root of x minus 3 is equal to y. For number 2, we have x squared over a squared minus y squared over b squared is equal to 4. So we have to again apply the rule, and let's see how we make x the subject of the formula with these examples. Now focus first for number one. Let's focus first to this example number one. So we have square root of x minus 3 is equal to y. So in this case, before proceeding to squaring both sides of the equation, we have to transpose 3 to the other sides of the equation, leaving only this square root of x. Okay, or you can add both sides 3 in this equation to cancel 3 in this side of the equation. But again, to what we're doing here is transposing it to the other side, like in this way. So by transposing it, negative 3 becomes positive 3. So we have square root of x equals to y plus 3. So now we can go ahead and square both sides of the equation to cancel square root here in your x, because that is just inverse function. So simplifying it, removing square root symbol here, we have x is equal to open close parenthesis y plus 3 squared. Okay, so therefore this is now our answer from this general equation. We have this x is equal to open close parenthesis y plus 3 squared. Hopefully you understand. Okay, so to sum it up, we transpose negative 3 to the other side because 3 here is not part of your x. So we add both sides of the equation with the same quantity, which is 3. Or you can transpose it to the other side. That's the reason why we have this 1 as pointed by the cursor. Now proceeding to squaring both sides in order to cancel the symbol for square root, we have this 1 now. Now let's have example number 2. So in this case, we have x squared over a squared minus y squared over b squared is equal to 4. So this is in a fractional form equation. So from what you've learned earlier, we have to make it not in a fractional form. So in order to do that, we have to identify the common denominators. So the common denominator in this example is your a squared and b squared. So we have to multiply both sides by a squared, b squared. Good. So putting that in this solution. So a squared b squared, both sides of the equation. So in this case, x squared over a squared is separated by an operation which is subtraction, y squared over b squared. So we have to do separate operation for a squared b squared in this one and the other one. Okay, so let's start working with this x squared over a squared when we multiply it to a squared b squared. So what you know before, we can go ahead and cancel common terms here to make life easier. So cancel a squared and a squared, leaving only b squared. So this is just only working for this particular part of the equation, x squared over a squared. Okay. Now you can go ahead and multiply b squared to x squared. So when you do that, you have b squared x squared here. Now we have to work now multiplying a squared b squared to y squared over b squared. In this case. Okay, so cancel. We have to focus here as pointed by the cursor. We can cancel common terms here now. So common terms are your b squared and b squared. So we can go ahead and multiply a squared to y squared. So the answer is minus a squared y squared. Okay, so I will repeat it so that everyone could easily understand it. Now the first step that we have to do is to make this equation not in a fractional form by multiplying both sides by the common denominator a squared b squared. So this we have to work on this given in your equation first before working in this part of the equation. So common terms are cancelled. So we multiply b squared to x squared, having this answer. Also, we use the same denominator, a common denominator, in order for us to work with this part of the equation. So cancel common terms, b squared and b squared, multiplying a squared to your y squared. So we have minus a squared y squared. Okay. So now we can go ahead and proceed working with 4 multiplying to a squared and b squared. So doing the same thing. Our focus is only on this side. Para lang hindi kayo malito. So multiplying a squared b squared to 4. Our answer is this. Equals to 4a squared b squared. Okay. So from this ways I explained earlier, we come up with this answer. B squared x squared minus a squared y squared is equal to 4a squared b squared. But we're not yet done here because our goal is for us to have a formula for x in this case. So here, upon analyzing it, we have to remove, okay, your a squared y squared in this equation, leaving only your b squared x squared. Okay. Later on, we have to work with b squared x squared. First thing, we have to remove this one as part of this equation on the left-hand side. Okay. So we can do that by adding both sides, a squared y squared. Okay. Or you just simply transpose this one to you just simply transpose this one to the other side of the equation. Okay. So hopefully you understand that part of the explanation. So we can go ahead and proceed now working with b squared x squared. So this is multiplication, the operation between these two variables. So you know what to do. We can divide both sides using this quantity, b squared. So both sides, in order for us to cancel this one, cancel b squared as part of your x squared. So leaving only x squared is equal to 4a squared b squared plus a squared y squared over b squared. But we're not yet done because this is not x, this is x squared. So the inverse function that we can apply here to exclude square root, the power here, which is raised to 2, is by putting a square root on both sides of the equation. So square root on both sides of the equation. We're doing this because this is the inverse way to exclude and cancel the power in this given example. Okay, so that's the time that we can cancel the square root here and the square here. So further simplify this one, we have x is equal to 2ab plus ay over b. Now hopefully you understand the whole procedures, okay, in order for us to properly manipulate this equation as pointed by the cursor into this derived equation.